We're breaking away from patterns because there isn't really much more interesting stuff to show you, unless we go in depth in patterns, and that's not what this series is about. So we're opening a new chapter for a couple of general things that you might be interested in, and starting today with a big topic to make up for last time: MSBuild, the infrastructure you constantly use to actually build your CS project. Files. Although sometimes you don't really notice that you use MSBuild. For example, if I am just in here and use the built-in functions in Visual Studio, it's getting called in the background. If you use the newer.net commands, well, that itself in the background is also just, again, MSBuild. So you can use basically the same commands as well. And the fundamental structures of the files in question is always the same. MSBuild, by nature, is XML. It's always XML files that are evaluated in a very special way. But the basic rules, like the grammar, what you can write, what you cannot write, which names to use for what, where, which characters are allowed, escaping, that's all just basics XML. And that's important. Sometimes we need special characters when working with MSBuild, and it's good to know which characters you have to escape and which not, and how to do that. But that's all the basics you can read up everywhere. Nothing special for MSBuild here. Now, MSBuild itself, I think the term MSBuild is pretty broad. I'm specifically talking about the syntax of the quote-unquote language that is used by MSBuild to describe build processes. Processes? Is it processes or processes? Doesn't matter. And I'm just gonna call this language MSBuild, this entire structure, but it's probably better to call MSBuild just the entire framework, so to speak, the entire system around it that's using the files, that's compiling all the background stuff that exists. But when I'm talking about MSBuild, at least for this on stream, I specifically mean the language syntax and how that works. Now, you've seen MSBuild before, whether you are aware of it or not. If we look at the project files we have for our projects, be they the newer format, which we use for .NET projects, or the somewhat bigger files for the .NET framework before, with the old style of formatting, they all are written in the same syntax for MSBuild. They always use the same rules. It's just that what's written in here is different, but both the old .NET framework and the newer .NET both use the same MSBuild. Well, that's a lie. We have newer versions of MSBuild. There are versions of the tool that can process these files, and with that come new features that accepts. But overall, it's still just XML in a special format for MSBuild. And for using MSBuild, you don't actually need a project or anything. You can start from scratch with an empty file. And you can run MSBuild on these empty files, and you can have it do stuff without any code to compile. In theory. Now, in practice, there's not really a reason to do so. You would use MSBuild to guide the build process, but for learning, we're just not dealing with building any code or libraries or whatever. We're just going to use the language features as is to show the different rules. There's no compiling going on today. Also, that's lie too, because right at the end we'll see some compilation, but not in the way we do so far. Let's talk about the actual language. Since we're using XML, we're gonna start with a root node. And for MSBuild, the root node is always a project node. And because it's XML, nope, that one, autocomplete kinda got on the way. We want to start the node somewhere, want to end it somewhere. This is now a project. And let's just try to run this file through MSBuild. If you're in Visual Studio, what you can do is open the developer PowerShell directly in Visual Studio. For some reason, mine is a bit weird today. I'm not sure if this gets through. If I'm looking at the OBS capture, it's not displayed, so I'm not sure how this is done exactly. Let's just make a quick screenshot. This is what I'm seeing right now. I did not cause that big black bar. That's on its own. You can barely make out the text, at least on my end. I'm not sure if it's getting through in stream, through the compression. But yeah, that's a bit weird. So I'm not going to use that. Instead, I'm using the separated PowerShell. It's the same PowerShell that we saw just now, the developer PowerShell, just in an actual PowerShell window. And we're gonna move into this directory. If you look in there, we have only one single file in here. Somefile.project. It's the same file I have open in the background here in Visual Studio. And I can just run MSBuild here. It's a known command, at least in the developer PowerShell. Be aware that the developer PowerShell gets some extra environment variables that are not in the standard Windows PowerShell. I think I don't have MSBuild on my path variable, so the normal PowerShell doesn't know MSBuild. This is the developer PowerShell. It does know MSBuild because it's provided with additional information from Visual Studio. If I run this now, in this current folder, it will just try to compile all the project files I have in there, which right now is only somefile.project. In theory, I can name this file whatever I want. I don't have to name it project. Also, project, maybe this is something interesting for you. This is why the project files are called that way. These are always project files. And in this case, it's a project file for a C# program, so it's a C# project file, a CS project. There's also, for example, Visual Basic project, VB. And I don't know for sure, but I would assume that for F# it works similarly with an FS project. But yeah, I'm just not tying it to any specific language because I don't intend to compile anything, so I just called my project. We can call them whatever we want, and we can also provide them as an explicit argument to MSBuild, which will then just use that specific file. And what you can see here is that for the second time I have an error, specifically this error down here. There is no target in the project. So it did recognize our file as a project file, but it's not a valid one. I'm missing a target. When we're talking about project files, I like to make analogies to programming, because that's usually easier to explain. The project file itself, or the project node, to me is like a class. This is like a top level. This is now the full-on structure. This is one project, this is one class. And I can add some more project files. We'll see how that can be done later. And those are different classes. And it's just for organizing. But these classes are empty, so I want to fill them with something. And target, the thing that's missing, is the equivalent of a method. Something that this file is supposed to do, or describes at least the process of doing it. So I'm just gonna add target. Actually, does it autocomplete? No. I'm wondering, can I just... No, I don't want... Why is autocomplete? Target. So again, I'm MSBuild, XML, so I'm acting a new node. And let me just quickly close and open that file. Maybe I get the... Yeah, that looks better. Let's try that again with target. Yeah, it's now also recognizing this as a project file, which it didn't before, and therefore I get the additional features like it's adding the ending node as well, or the ending tag. No. Now with this, I have a method, sort of. That's not enough though. If I try this again, get another error. Required attribute name is missing. In MSBuild, almost every node you're gonna use will have a bunch of attributes. XML attributes. And they always have some attributes that are optional, and sometimes they have some attributes that are non-optional, that you have to provide. And target has one such attribute, the name. Just as with programming, our method needs a name, something to call it by. And I'm just gonna call it our method, because the actual name doesn't matter. It's completely up to us. And with that, we actually have a valid program. So let's try that one more time. This time, build succeeded. And MSBuild is designed for builds, so it's always in the context of I'm building something, but that doesn't mean it's actually compiling. And all we see here is it just worked. Let's maybe clear out the old stuff and try again. So, starting MSBuild, and no errors, no warnings, just succeeded. Everything worked. We want to do stuff now in this target, in our method equivalent. And for our C# program, that would mean writing out code. The equivalent of actual code in MSBuild is a task. If we think of C# code, we have individual instructions that we separate by semicolon. Then in MSBuild, we have a task. A single task is the equivalent of a single instruction. One thing that we want to be done. And one predefined task. There are a lot of tasks that come with MSBuild that just exist and we can use, is message, which has one required attribute, text. And we're not gonna add an ending node here because this is just gonna be the node on itself. And it's basically just a standard console out. We go back to our console and run this again. You can see some more. You can see some output in here. It's telling us it's executing our method. It's running the target. And then in gray, you see the output of our message. And some more output telling us it's done. If you compare it to this up front, the empty target, we have some additional output now. This output might be hidden depending on where you run it. For example, if I use the standard built-in developer PowerShell in Visual Studio, I usually don't get to see that. The output you see in the PowerShell or the command line, if you use that, whatever you use, has different tiers of visibility, and you can change at what level of importance do you want to see a certain message. And this PowerShell right here includes everything, which is pretty nice for debugging. Can be a bit annoying when you just want the output, the important stuff. So if you use, for example, the Visual Studio one, the built-in one, and run exactly this, let's call it code, you probably don't see any output. We would expect that as part of the build process, you see it in the output. If you go to the dropdown for build or build order, you would see a message, but only if we set the importance to high, like a priority. By default, it's filtering out anything that's below. The standard message is hidden because it's not deemed interesting enough. The standalone PowerShell has its barrier a bit lower, so we do see it without the importance high. But you can see a difference nonetheless. This one is much more visible than this one before. Well, this is the basic. We have a project file, which has one root project node. And in this project file, we have a target with a name that's important. And in this target, we can add now tasks. Different tasks that can do or cause different things. We can also add another target. This other target must have a name as well. Let's name it function. Let's pretend this is a function we might need to call. And let's just copy this out. Hello from the function. And let's keep important high. Why not? Doesn't hurt anyone. So if I run my code now, what will happen? What do you think happens now? This is our program. We have two targets. Our method and function both have a message they would output. 3, 2, 1. Okay, so this one output, we did see it. This one, we didn't see. Not in here. Let's flip the positions. Let's try again. So it does execute the first target it sees, but not the second. We can change that. One way is through the command line. We can specify target with the T attribute, and we can tell it which target we want to run. And say function, and it will execute the function. I can also give it our method. Wait, did I call it our method? Yeah. And hello Twitch. I can also our method. Well, let's maybe make this the other way around. Function. So you can see it's one line function and then our method. I separate them with a semicolon. And it didn't work. What have I gotten wrong? Was it just a comma? It was just a comma. My bad. Mixed those up. Don't use the command line option as often. So with this, we determined to run function and our method. And we can reverse this. Run first our function, our method, and then function. So using the command line argument, we can determine what do we actually want to run in this file, regardless of the order of targets in here. We don't have to do that with the command line though. We can do that in here as well. We can determine default targets, which by default is the first target we have in here. We can change that to our method, for example. If I just run the original code, some file directly, we get hello Twitch, despite it being the second, because we determined that is what we want. We can also put both on here. Notice it's targets, not target. Plural. We can provide more than one, and the end result is basically the same as we had with the command line. Only in here it is the semicolon. In the command line it was just a comma. I forgot that part. Now, we can also do this manually, sort of. Let's put that specifically in here, that we want to call our method. This is the target we want to run if we build this project file. And then after we get the message here, we want to use another task called target. And as the name suggests, it's calling a target. Notice it's singular, it's not plural. We call a singular target now. And targets accepts plural again. Really? What is it? I had it in my head as singular. Was it plural after all? Huh. I don't remember it being able to call several targets at once. Well, that's good to know. We're gonna use it as just one call, and it's for function. So the project says we start with our method, only our method. That's where we get our entry point, so to speak. And once this is done, our project is done. But our method internally uses call target, the equivalent of an instruction that calls a different method. It's calling the other target function manually. So when we run this code now, get hello Twitch and hello from function, because we specifically call this other target again. This one is a bit interesting though. In theory, if this was C# code, we would expect our method to be called first. So we get this output once, then we call function, so we get this output, and then we call function again. So we should get this output twice in a row after seeing this one once. But if we just look at the output, one hello Twitch, expected. One hello from the function, expected. But no second output. This is where the analogy to C# code falls flat a bit. Targets are one time only. If a target is called, it runs to completion, or at least until it determines it's done. And then you can never use it again. It's like a consumable. You can use each target only once. There's a sort of workaround where you actually call the entire build process once more and then specifically call the target. That is kind of a workaround. Bad one, but it is one. But in a normal process, in a regular single MSBuild call, each target can only be run once. If you call it a second time, it doesn't work anymore. Let's try another duplication. Actually, let's keep that in here. I'm just gonna copy the entire function. This should not work in C#. We have two targets named function, which means two methods with the same name wouldn't be allowed. It is allowed MSBuild. The difference is, in MSBuild, it is simply deciding, well, you already have a target named function, but since you wrote a new target here, you probably meant to override the old one. So I'm gonna do that. So this is function 1, this is function 2. Let's see the result. We're getting from function 2. Call target didn't profit from this at all, because function still exists only once. This target, the named function for a target, is just overwritten with the next definition we find. We always start at the top, and whenever we find a new target with the same name, we overwrite the old one. So you can create a new target and accidentally overwrite another existing target. So you have to be careful with naming. If possible, don't make single short names. Try to be long in your names. Make something distinct, something unique that, you know, no one would usually write if you actually have to create your own targets. So there are things like build or clean, the classic ones. Those are existing functions that are already in use, and it's probably not a good idea to override them. And if you're working in a team and you all have to do something in the MSBuild files, be aware of that. You can accidentally override an existing target with your own, and you wouldn't know it because there's no warning for that. No error, it will just behave weirdly. And debugging MSBuild is a pain. let's talk about parameters. Oh, actually, wait. No, I think it's better if we start with this first and then talk about the parameters later. Actually, I don't mean parameters, I mean properties. Dang it. We already went down to the level of calling it manually. There is another way we can cause all of this to happen. Our method is now directly called when we run the project. We can introduce some link between different targets without explicitly calling a target. And that happens through an attribute, or a series of attributes actually. We can, for example, say that our method depends on targets and then call function. Just call it function again. So what we're telling the system now is that we are called our method, but for our target to make sense, for this stuff inside to actually do its job properly, some other target has to be finished first. So it will first make sure that the other target is called, and then it calls our target. By the way, if we explicitly call function first directly, either through the command or because it's in the default targets or whatever happens, that doesn't really have any effects because the system will notice that function has already run, so we can run our method directly without specifically calling function again. But if you don't include a call to function anywhere, this depends on targets attribute makes sure that it is called. You can instead go the other way, and instead of telling our method to call function first, we can tell function we want to be run before our method. Same result, function is called first before our method. The difference is that we defined this behavior in function. We basically added a hook onto our method. Our method didn't know anything about function now. It just executed, but the entire MSBuild process knew that function is supposed to be called before our method, and we determined that in function. We can also do it the other way around. We can also say after targets. And we still hook ourselves into the other target, our method. Just this time we wait until it's finished and then execute ourselves. That doesn't mean we get executed directly after our method, it just means that sometime after our method is finished, function will be called. There may be other targets that also are hooked into our method in some way. So they might be called first. And you can also combine things. You could add some other things like it has to be called after our method, but it depends also on another target you have to call first. You can make a lot of dependencies in between targets using these. So that was depends on targets to say call this others first. We have after targets to say call me after this is done, or before targets, call me before this other thing is done. So we can introduce some interesting dependencies between the targets, so we don't have to manually call target or add the different orders in which we execute targets into the attributes or the command. Well, this is, by the way, something you will use a lot. You're probably working with MSBuild because you're extending the default behavior of the build, so you probably want to hook into the existing build targets, like build, or I often have before build, because I have to prepare some files, and after build, because I want to make some cleanup happen. Cleanup itself, I also hook into the before clean. Or I hook myself into the clean target to make stuff happen there. So these dependencies are very, very useful. Enough of that. Let's talk about. Let's move a bit. And just will clean up a bit. Let's talk about the properties. We have classes and methods and instructions. We have to store data somewhere as well. And properties can exist both inside a method, so we can add them inside a target, or we can add them directly inside a project. It looks the same way in both cases, so I'll start with some properties inside the project directly. To define properties, we have to first create a special property group. Anything we do in here is seen as us defining a new property. We can say, for example, who, and give it the value bar. And with that, we have now successfully defined a new property, who, which contains the value bar. We can also add another one, hello, which the property hello. We can add as many as we want. We can also add empty prop. And so do this, which is literally an empty prop. Doesn't contain anything. I mean, it's the same as doing this, just shorter. Though this is usually not needed, because if you don't have a definition for a property, MSBuild will treat it as still, yeah, sure it exists, I'm just gonna pretend it's empty. You never have no value, or null. How do we use these though? Well, let's say I want to output this value in this message. We use a special syntax. We start with the dollar symbol and then normal brackets. And this is, if you don't escape it, treat it as reference some property that exists. MSBuild will treat every occurrence of dollar sign with two brackets, one opening, one closing, as a special call reference to some property. And I can just use the name of a property in here and run this now. No, not that one, that one. It says switch. Let's call it world. Now it's world. So it uses the properties we have defined up here. If I use empty prop, well, it's just an empty string. So we have the space and then directly the quotation, exclamation mark, sorry. So we have the space, exclamation mark, and the empty prop in tree is zero length string. And if we do this one, well, we have never defined it, but as mentioned earlier, doesn't care. MSBuild will just assume it's empty. So it's never null, it's just, no, it's an empty string. If you haven't defined it, we'll just treat it as a property with an empty string. Again, another case where debugging is a bit of a nightmare, because you can never be too sure if you actually have defined it somewhere and it's properly recognized and just doesn't have a value, or does it not know a property and it's just using the default value. Can be a pain to debug. We can, by the way, use the special syntax inside a property definition as well. So if I do this, go back to hello, we get bar. if I want to have this as an actual value, you have to escape it somehow. And was this one? I think it was, I know it was 25 and 24. I don't remember in which order. Like this? Let's just try it. No, that was not it. 425? God, I don't know. Okay, 24 then. So what I did here is I used the percentage sign, which is another special character. It has more than one use though. In this case, I used it to determine, hey, please at this location use the ASCII character with this value. Use this code point, 24, which happens to be the $sign. So this way I get the actual $sign foo in here. If I use the $sign up here instead of the escape value, it would treat this as, oh, it's a reference to another property, so I'm actually loading that. Very important sometimes. Let's add another property group in here, this time inside our function. And let's just go with the empty prop. Set it to empty. Let's say before talking about method, yeah, let's go from function empty equals, and then let's make a reference to empty prop. Hello. Empty equals some empty prop. So let's try to figure out how this might turn out. We have our empty prop defined up here globally, directly in the project file as just empty. Just determine that, yeah, this is an actual name. Doesn't really do much because, again, if it didn't exist, it would be treated as empty as well. But inside function, we give it actually a name, actual value internally. So this message should pick up this value. Correct? Seems logical. We define the property group, and the next thing is we load that value. Our method also uses empty prop, and because function is called before our method, this value should be overwritten. But then again, we have empty prop up here inside the project globally, and one's down here inside function locally. So maybe this is a different property that hides the global one, and we're actually referring to just the local version. And this is a separate one that's then used in our method. Well, let's see. Both are empty. Let's switch this around to after targets. So we first have the output, and then this is overwritten. Seems correct. So based on this, we could assume that standard logic, we call this first and start with an empty value. But as soon as we hit another property group that overrides the old value, we use that one instead. But they both refer to the same value that's stored in MSBuild. Let's make a quick change here. Instead of making that via dependency, let me make a call target. Call target targets function. So we do expect we call the target here. So empty prop should be empty. It isn't though. It is actually empty, not the name, not the text empty. So if we do this, this value will be the original one we defined globally. But if we do it like this, it is actually overwritten by function. So what's going on here? MSBuild is a bit weird. I don't understand why, but what you can think of is the moment you enter a target, the moment you start running the target, you copy all the values that are defined so far. So everything that exists, that has a definition anywhere, or doesn't have a definition, whatever, is copied, and that is the set of values you are going to use inside your target. So our method is called in the beginning. At that moment, these properties exist and are copied, and so they are what's used inside this target. You can actively change them within this target directly, but anything that happens that's not directly inside this target, in this scope, so to speak, is kind of ignored. Because the call I make here, call target, let's actually just return. Oh, that was it. The call I make here is causing the same to happen for function. I make call target, and when I do so, all the pre-existing properties that are known are copied once more, this time for this target. So we have now two copies of all of these properties. One copy is for our method, and one copy is for function. Now function internally does actually change these properties, and when it does so, it's doing that in its own copy. So we have the original values, which are empty, we have the copy for our method, which is still empty, and we have the copy for function, which actually is filled. When this target is completed, when we end this target, the internal state for these different properties will be written back into this global storage. So once we hit this line, so to speak, once this call is done, we only have two versions of the properties. We have still the original copy for our method, where it's an empty value, and we have the new state of the variables because of the changes from function. And now message is getting called, which will refer to its own copy, which still doesn't have a value. And then it exits and will apply its changes to the properties. It didn't make any changes, so it doesn't change anything. It will still use the build value of entry prop afterwards. Excuse me for a moment. Sorry, that was a small interruption. Where were we? Property. Right, the copies. So this is what happens when we call target in here. Basically at that point, when it's called target, or when it's calling the target, we already have our copy for our method. When we do it through before targets, our method is called after function. Because we do it through before targets, the MSBuild system will first call function, complete the call, and then we'll call our method. So we first get the call in function, we make the copy, we change the copy, we end the target, and we copy our changes into the global storage. So now the global storage has the value empty. And only now is target for our only now our target, our method is called, which will copy the global values, this time including the word empty, and so it can output that value. Well, just keep that in mind if you ever have trouble with the properties. The moment the target actually starts executing, we make a full copy of all the properties as they exist at that moment. And when the target finishes, we copy all the values back to the global storage that we changed. Only all our changes are only applied after our target finishes. So call target and before target, there's a difference. If you use it indirectly, the dependencies, the properties will behave the way you expect. If you make a call target and call them manually, you might get some unexpected behavior. But then again, maybe that is wanted. Maybe you don't want this other function to give me wrong values. Maybe you want to have basically a copy of the values from before the changes for comparison or for some output. I don't know. Just be aware of it. By the way, property groups, you don't have to do all of them at once. You can have several of them, one after another. You can split them up into single ones. You can rewrite them as many times as you want. Property groups don't have names. It's just a way to let the system know that you are now declaring or changing properties, and it doesn't try to interpret these as some other thing. Property group surrounding the actual properties is more like an escaping method. That is properties. Properties are only one of two possible types in MSBuild for storing data. Property is straightforward, a name, a value. There's a far more complex type, and it too requires a special group for defining it, just like property group. It will actually look like property groups a lot, and it's called item group. Now, item groups let you define items. So I can have foo, which is now bar. That's fine. Let's ignore the empty. Hello. Let's make this a simple value. So we keep hello for the property as a reference, just for comparison. And we have our item foo, which contains right now the value bar. Now this will just work. If I call this, it doesn't work. Let's look at the error again. So we can declare a new item, that is fine. But we can't just fill it with a value like with properties. In case of items, we do that with attributes. And the one we're going to use is include. Now let's try this again. It worked. But we can actually see the output, right? So, hello from function. Or function or foo. And let's maybe add the output. So before we used this. That's not how this works now. You can see, empty. This property doesn't exist, so of course it's empty. This is the problem. The $sign only works for properties. For items, we have to use a different symbol. We use the @ We use an @ and call this again. We actually get the output bar. So, similar to properties again. Let's try something else. Let's do this. If I define or declare a property a second time, it will overwrite the old value, and that's what we get. For items, we didn't directly write the value. We included it, and that has a big impact. We get both of them. And by default, they are separated by a semicolon. So this is now a single item that contains two values. Wrong key comma. That. And we can add as many items as we want. Although we are not limited to semicolon, if you don't like that, we can do something else, like, for example, a pipe symbol, different separator. You just add a comma and then provide the separator you want as a text. These are not single quotes because it's a character, it's just how MSBuild operates. So items are similar to properties, but they are more like arrays then, I guess. Can include data. I can also was it not in here? Okay, you can remove data. I am not sure if it's accepting that. Maybe I have the wrong MSBuild version. It did. Alright. So, comparison before, bloop was included. This time it wasn't. Because we specifically removed it. My autocomplete doesn't show it yet, but my MSBuild version is up to snuff. So again, looks pretty much like an array. We can do some more stuff. We can include several of them in one go. We can use the semicolon again, the default separator, to include several at once. So with this too, you can just get bar and add of text. If I don't remove loop, I get both of them. As you see here, it's not the one text bar semicolon bloop, it's treated as two separate items. And because they're separate items, we can actually make use of another value or another attribute, exclude, which can filter out data while you include it. Instead of removing it later, you can exclude it from the get-go. Only bloop. You can do some more stuff actually, but let's maybe talk about what items are usually used for. Properties are a single key value, just a string to store. Nothing more, nothing less. Can contain configuration data or whatever. Items. Items are used to store complex data, and usually they store files, or at least file references. See, what I'm doing right now is I'm providing just straight up values, strings in here to store. But instead I can provide a path. And one path we will always have is this one. You can see the dollar symbol in front, which makes this a reference to a property. But we never defined this property. We didn't need to. It is one of many well-known properties that just exist when you start the MSBuild project. And there are a couple of ones, or very useful ones, that start with MSBuild or MSBuild project. So I have right now the path to this very file, this sumfile.project. That's the reference to this file itself. If I run this code now, get sumfile.project. We can actually use individual values from this. Now that the system has actually loaded the file and not just a single string, let's not use a separator in here, we use something else now. We make a little dash greater symbol, and this is now used as basically as accessing individual properties of this item. Because item is not just an array of strings, it is an array, kind of, or more like a list maybe, because you can freely edit it, but it's not of strings. The items we used so far are just strings, but internally it can store so much more. Items are basically lists of dictionaries. Each individual item we have has itself a set of properties we can access. And with the syntax, with this little arrow, well, let's actually make it shorter. I'm not sure if it's sensitive to whitespace. I haven't tried that. Let's try that with whitespace for now. We can access individual data, and we then provide a little format string, so to speak, that lets us access the different properties of this one item. And to access these properties of an item, we have the same syntax with two brackets and a special symbol in front, and this is our third symbol, %sign. This is why I said earlier that the %sign is used for more than just escaping. It is also used here. And what I can do is, for example, identity, which is essentially the full value of, or the standard value for the output. Sumfile.project. It is basically now the same as just going add foo, like before. More interesting maybe, something like directory. If I go for directory, I get actually the directory of my little file, excluding the root directory. So let's add that maybe. Let's add another property directly in front. Root directory. Now we have the root directory plus the full directory to our file. And then we could add sign file name and, for good measure, extension. And we save and we call. And now we have the full path including the file name and its extension. And you also see that the other property we added is actually treated as if it was a file. We have a full path. End of text. We don't have an extension, but we do have a file name. So what we did before was actually kind of cheating. We used the system for something it was not intended for. So the default properties that are just in items always don't make too much sense here, but we can access them. And since we didn't provide a path in here and just gave it a name, it assumed it is the name of a file. It doesn't care if the file exists. And if it's just the name, it will assume it's next to this project file. It will just treat this as a relative path. So it assumes it's the same path as our file itself, which we see up here as well for the actual file. And it will just add the name of the file that we arbitrarily decided in here and the end. Might make more sense if we do this. So it looks more like what you would expect. Just referencing a file, whether or not it exists, doesn't matter. That's not what this item is for, it's just for storing the path. Though it can access a bit more information. We can, for example... Let's use modified time. Can access actually some properties. So this is my current time. There are a bunch of predefined properties, or properties an item has that you can look up. They're pretty useful, and with this you can create a nice little output. Maybe you don't want them in one line like we did though. So instead what we could do is this. Actually, did I get that right? I'm wondering. Let's just try it. Nope. Food identity. Look like this. Honestly, I can't remember how to set the batching up. Nope. Wait, let me just quickly look something up here. Oh, yeah, I already did. So we can do this, just referencing. Foo identity, or maybe... Foo, and then the rest. Yeah, something like this should work. Yeah, that looks better. Batching has some interesting formatting rules, so I'm not too clear about that. I know it exists, and I think I've used it at one point, because I needed it to create some data. But basically what you see here is the difference. We have, instead of putting both values just as a list of semicolon separated values. So instead of going from hello from the function for foo and then first string semicolon second string, we repeated the entire instruction. We repeated hello from the function for foo, then our data, and then we did the whole message again. Hello from the function for foo, the rest of the data. We use the percentage sign here for the item directly, and that's what triggered the batching. Can I actually do that like this as well? Nope, I have to access the data. Oh dear, you should be able to do it like this. the modified time in the end. And let's remove that. So that should give us just the path and the modified time. Yep, that's correct. So that was my mistake. Instead of having that as a formatting inside the item within the add, I basically just use all the formatting, making sure that at least one of them has a reference directly to the item I mean, and the others are inferred from that. The others are just inferred as, okay, I'm referring to foo, and I have to use the percentage sign in front. Okay, that's batching. That would be the difference between having that as an add. And I don't want to redo all this. Okay, let's copy this and go back a bit. Data switch. That. Like that. Yeah. Sort of. And from through normal. And batching. So normal has all of our texts, and then we have a semicolon in here, and then the next item starts. And for batching, we have just both called separately with just their own values. And the thing about batching is with this percentage sign, it applies to every task you have. Right now I'm using the message task, but whatever task you have where you use this item as a batch, it will just repeat this same line for every single item you have in that item. In the list of items, that's weird. This is an item, but it has several items, entries. It will repeat the whole thing for every entry in your items list. Items are a bit strange. So yeah, you can have different values in there and reference them like this. And besides the predefined one, you can also add your own. So what I did earlier, I don't want to escape this, thank you, was I just added value in here. That doesn't work for items because this space is basically another property group. So defining an item or declaring it, changing it, you can treat this as declaring a property group for that item. So special value, totally cool. Yo. And I can reference this. In here. And if we run this code again. Yo. So just like normal properties, you can also edit, change the properties inside an item. And with normal properties, or just the same as with normal properties, you reference something that doesn't exist, it will just treat it as, okay, it's just empty, no problem. Now going back to the whole logic of this is a path. If I don't specify a specific file, I might specify a general name for a file, or just a directory in which there are files. And to deal with that, we have special placeholders we can use. And they're actually pretty simple. We have 3 different types. So I can use some file project. Let's remove the old one here. Not all of that, just that one. And let's just output foo. So I'm referring some file.project, which exists. Some.project, sure. Ah, no, I want to see the rest of the data. That was a mistake. Sorry, it's getting late, and let's just format this again. What was that? Get root here, then followed up by the directory. After the root, followed by the name, file name followed by the extension. Wait, couldn't I just get the... Wasn't that... Yeah, I think I could just use file name. Wait, which bracket goes where? Right. Item some file. Okay, no, that didn't work. Let's return to the old one. No, that's one too many. Like so. That looks good. So that's our file. And I can decide I'm not too sure about file. For example, was an uppercase, lowercase, question mark. Question mark is one placeholder you can use. It literally means I don't know what at this position would be written. This one character, I don't know what it is. Could be anything. Just accept any file that has this name with anything for this question mark, except for path separator signs or characters. Keep in mind, this is the path. I'm using only file name, but I could add a separator like this, path separator. So I include a full directory. Maybe it's not directly in the same directory as my project file, but in a subdirectory. Or maybe it's one directory layer up and then in a sibling directory. This question mark can only be used for normal characters inside a single file name. It cannot replace this path separator. So it can only be used for file names themselves. And if we're not sure about the entire name here, well, we can use also the asterisk. Asterisk is a placeholder that can replace many files, or many characters, or none. So question mark would be a placeholder for, at this exact position, there's exactly one character that fits. Pick any file that matches the general criteria otherwise. The asterisk means, at this position, there could be any number of characters. There could be also no characters at all, except everything that fits that criteria. Again though, it excludes directory or path separators. So this is still referring to just a single file name within a very strict directory. Well defined. And then there's this, two asterisks. Two asterisks can replace everything, including path separators. So this could be a file named directory sum.project. This could also be directory, and in that directory we have some file called sum.project, or maybe some file.project. Or this could also be a subdirectory with 100 subdirectories, which at some point in the end contains a file with sum and something and .project. So we have question mark for single characters, a single asterisk for 0 to as many as you want characters, and then there's two asterisks in a row which replace or stand for anything, be that path separators, So you can include subdirectories or just the file itself. So we'll do this. We will start at the directory of our project file. And basically, whatever we have that starts in here and has any path separators, and then sum, and then project, we accept it. Let's simplify it to just some project. We exclude the directory stuff. That can get a bit overwhelming. So do this, and it did actually find some file.project, because this did actually look something up. As you can see, that's not the original name. It did find a matching file, and it used that match for our output. And that's also why the exclude can make sense, because we might want to accept all the files except for some file.cs, oh, some file.project. Let's try that. And suddenly we don't have any items at all, because the only file it found that matched this criteria was explicitly excluded. And by the way, you can also, oh no, not foo, foo2, include and add foo. We can actually do this. What will happen is that the add foo is evaluated as a reference to an item, and so it's basically written out the same way it would be in our message, with just the different files separated by semicolon. And that just happens to be the exact same logic we need for the include, which accepts a list of files separated by semicolon. So now foo2 is a copy of the first one. We can do this foo. And we can do foo2. That's foo. We copy foo into foo2, and then we're gonna do foo remove some file.project like that. And if we run this code now, foo doesn't have anything. Let's maybe make this correcter. That's better. Foo doesn't have anything because we specifically removed the only content, but the copy we had before into foo2 is still here. No problem. So just as with properties, you can reference other items when declaring items, and that way you can also filter them out. So instead of doing a remove, you can just make a copy and then during that copy have an exclude that removes something. Lots of possibilities. Now we have properties to store data. Let's ignore items for now. Unnecessary complications. And we have the ability to execute code. Now let's add branching. Right now, all the targets are executed as predefined, no matter what values we have in here, and all the code in each target is fully executed, no matter what happens. We can limit this. Almost all nodes have an optional attribute condition. And conditions are Boolean expressions, or just anything you want actually, that are evaluated as Booleans. And if the end result is true, then nothing really changes and the node is treated as, yeah, this is a node that exists and we're gonna execute the target or run this task. But if it evaluates to false, then MSBuild will completely ignore the entire node, as if it doesn't exist. So if I do true in here, just the most direct way, true, and run this code, we get hello world. And I made a mistake. I deleted that output. Hello from function. Let's try it again so we can actually see it. Hello from function, hello world, both worked. If I do this as false, well, only hello world gets output because function doesn't get considered anymore. Which gets interesting if we remove this and do the depends on, because now the dependency chains get affected. We'll run this now. It still executes. Why? Don't tell me I have that wrong. I think I have that wrong. That's interesting. Well, never mind then. I'm too lazy to figure out if it's because of our default target or because of some other feature I'm not aware of. At least the default case is still working, so this is just hello world is output, not our other function, unless this is true, in which case it is included. And for conditions, we can do a lot of things. We have, first of all the classic comparisons you know from C#. I can, for example, compare two numbers. 1 equals 1 is actually true. 1 equals 2 is false. No output. 1 is less than or equal to 2. What is it? Oh, right. That's a bit problematic. If I do this and try to run this, get an error because it's not escaped. Let's see, we have to use the escaping rules. Was it this one? Yeah. So that's XML rules now. Before we had the less than signs or the greater signs when we're working with the items inside a string, inside our text, where it was naturally excluded. For some reason, it doesn't deal with that well when it's in here. Right, forgot, because of the, yeah, it was less than and not greater than. Anyway, escaping rules. The greater sign can't be used directly, so we have to put it in an escape form, so XML doesn't treat this as we're starting a new node. And less is just the ampersand with an LT for less than and a semicolon before the greater than. And if you need the question mark itself, we have, I think it was just amp for ampersand. So with this, we have 1 is less than or equal to 2, which is true. Make it greater than. It's no longer true. So we can actually do comparisons that actually treat integer values as integers, and we can make comparisons that way. But we can also have just text comparisons, which is the default, where we just have an equals or not equals. And that means we can also include our properties in here. That's not what I wanted, but we can say hello equals which. This should evaluate to false, because we overwrite it as world. But we can test it for world as well, in which case it is included. And to be sure we don't get any weird values, you usually would put some quotation marks around this doesn't have any special meaning. It's just that we have now characters in front and after the values. So if this property, for example, doesn't exist at all, it will just evaluate to an empty string. And in that case, you still have a valid string on the left that you can compare to a valid string on the right. Otherwise, you might get a weird situation where you have nothing on the left to compare to, but don't do this. So let's try just foo. This is just false, no problem. If I don't add these and try again, it also works. Why is it? Am I really that out of touch? I feel like I've forgotten years of MSBuild knowledge. Like I can... Wait, was that just when... No. But I'm not even trying to figure that out. Why I thought that? Just make... Well... I'm still holding on to that belief. Because I know it was used somewhere, required somewhere, so... I would always do these quotation marks. So I know for sure that this is a valid string on the left, and I can safely compare it. But maybe I want to not only check this one value, but a second one. And for that, we too have the Boolean operators, though we don't use the C# versions. We use the written out versions, at least for and or. We also have the not, which isn't written out for some reason. So we can have this, or we can have hello equals, let's put that in quotation marks, hello equals world. So either foo equals world or hello equals world, and that is true. We put this to and, it is wrong, because foo doesn't exist. And we can have brackets, which lets us combine things. Just logical operations. And let's put a not in front. And this is true again. And conditions can be placed inside the target to make the target appear or not. We can put that in a message itself, which for us will have now the same effect as before, because it's the only content of our target. The difference is that the target is actually executed. We can also add it inside property definitions, which right now doesn't make too much sense because it is the condition that overrides world, or overrides hello with world, and we check for world as an option. But that means you can have another property control the second property. We have actually a property named foo. And let's just make this more easy to understand. Either this is true or this is true. This cannot be true. This is what we control. Let's just remove it. So based on the condition of foo, we can change this condition. And maybe... let's move it like this. And let's remove the condition in here and just hello from function. No, we output hello as well already. So default behavior, hello Twitch. Override hello from world. So the state of this property has allowed us to change the state of another property by simply overwriting it with a new value. And again, condition can be used in almost every single node you have. All right, there's one interesting condition, one check you might want. If we go back to item group and an item, let's put it like this, and include equals some file .xml. And we can make condition in here. Maybe we want this method to only execute when we actually have a file. Some file XML doesn't exist. We are in some file.project. And we only want this method, for example, to run when we are inside, or if this file, if an item exists as an actual file on the hard drive. Exists is a built-in function, so to speak, that we can use to test if a specific file or directory exists. So we can give it a path, and if whatever we have in that path is actually there, directory or file, doesn't matter, this will return true in a form that can be evaluated for conditions, as it just generates true. And if it doesn't exist, it will return false. So we can give it, for example, our item, and so only if some file.xml exists will a function be called. Let's try that. Function is not called. Let's try function.project, some file.project. Function is called. And this can be very, very interesting when you want to use functions that, for example, interact with that file. So we want to make sure that it actually exists. Alternatively, you could run the target, because maybe you want a proper error handling for that case. You don't expect it to be not a real file. So you use a special task called error. Text, which can have some output. File doesn't exist. Let's look like this. If I just call our code now, we'll definitely get an error. File doesn't exist. This time the build failed because of our own decision to abort. But if we add the condition, let's make it an not. So again, some file .xml doesn't exist. Some file .project does exist, and so our build succeeds. And just like error, there are a ton of other useful tasks in MSBuild that can do a lot of the things you want to do. Lots of predefined tasks that can solve all kinds of issues. But not all of them can solve your specific issue. And so there are some additional functions you can use to extend the capabilities of your build process. Just like exists, not in the same format, but similar to exists, there are a lot of predefined methods and functions that you can use from the get-go that interact with your properties and your items in specific ways. For example, our properties here, you can treat them as a string in C#, or at least similarly, and you can call methods on them. So for example, hello, if we treat it as a string, we would have a dot operator and say length, and it would give us the length of that string, because there's 5, which is correct. Or maybe want to place Twitch with stream. And what did I do wrong? What did I do wrong? I did something wrong. Oh, right. Yeah, it was overwritten, of course. I have to override world. My bad. That's better. So that's, for example, some pretty simple methods that you can use as if this was .NET, just a C# code. Just string methods. Not all of them exist, but some. And those are pretty useful. I'm sorry. Let me drink something. All right, so these dot functions you are familiar with from C#. These are a type of property method, and they call them property functions. Sorry, property functions is what they call them, not methods. There are other types of property functions that don't directly interact with the property directly, like the dot operator, but you can use them similarly to C# code. For example, I can use the old syntax of just the $sign and the brackets. I didn't want to change my language, thank you. And I can use existing methods from certain classes. I do have to specify though which exact class I mean first before I can call the function. And let's leave this one alone and let's do it in here. Yeah, we already have the system that checks if the file exists. And if it does, what we want to do is, no, not that. We want to call a method from system.io from a class you already know, the class file. And the full path would be system.io.file. And that's just to specify which specific class we want, the full name, including its namespace, inside square brackets, followed by 2 colons. And this is now giving us access to that class's methods to a degree. And the method I want is read all text. The actual method from that class that you might know, which receives a path and returns a single string which contains the entire content of that file. And what path do I give it? Well, naturally, an item. The file that we just confirmed exists. So when I run this, it failed. Of course it did. Because it's not translating this part, is it? Do I have to output it as an identity? Okay, let's make a simple workaround then. Let's property group path, and that's then an item. And we want the full path. That's an item using the logic we just learned. Item. Wait, no, that was correct. Was it like this? Or was it an... No, like that. Root dear. Was it? God, look at me, I'm totally confused right now. I can't remember just what I did. Do I have the old code still? I don't want to write it out. The autocomplete is not doing that for me, so I have to actually write it myself, and I am lazy, chronically lazy. No, it definitely was with. So quotation marks, that like that. Yeah. Here, and then directory, followed by not an item, but file name, followed by extension. And that's what we store in path, which is a single string, which we can reference in here as a single string, which should work. Yes. All right. So if the file exists, we can output its entire content now. Oh yeah. Excuse me. Apologies. Oh yeah. Didn't hit the mute button in time. What is going on today? Didn't take my medicine. Ah, crap, it's... Ah, I should have taken that hours ago. Okay, I have to remember to take my medicine in a moment. First, finish the stream. There are a lot of different methods that work in this way. There are also a lot that don't work. There's an entire list of that online. Microsoft has documentation for that, including also documentation for the other stuff like the predefined names inside items or properties inside items. You can look that up. Like, just look for property function. Just search MSBuild property function and you will find an extensive list. Well, let's say even that is not enough anymore and you need something even more specific, something that isn't covered by standard tasks and cannot be achieved through combination of different techniques and the property functions. You can, in that case, always opt to completely make up your own task with actual programming. You can actually write your own code, compile it to an actual assembly file, a DLL, that is loaded into your MSBuild project and then run as a task. You can do that. I don't see when this is really useful, except for some niche cases. It's not that I don't think the opportunity to create your own tasks is not useful. I use that. It's just the hassle of actually compiling an assembly file that you load and then having to always include that assembly file with your project and then constantly having to update the DLL, including its source code, and then that's all a lot of meh. Luckily, there's a way easier method, which for me works perfectly because when I write a custom task, when I really need it, it's still just a few lines of code. You can have actually that source code included directly in your CS project files. This is gonna get a bit more convoluted, so just stick with me. First, we're using a very special, I can't call it task, very special node. The using task. Now, using task is used for essentially including a specific task into your project, and that task might be from a DLL you load in, from an existing assembly you have, or it might refer to some code you now create yourself. And we're gonna opt for the later one. We're just gonna create our own code. And for that we start with first a name for our task, which is mandatory. And we're gonna call it I have to think of a cool example code that we can use. Or not cool, just something that shows off with some features. Yeah, okay. reverse text. Let's put it that way. That's something interesting, maybe. Then next, we're gonna need an assembly file. So because we are providing source code, we need some way to tell the system how to compile and use that source code. Actually, we're writing C# code later on, just straight up C# code. That is then used inside the build process to compile C# code, for example. So it's like the chicken and the egg. If we are right now the stuff that's compiling, where do we get our compiled stuff from? So we refer to an existing file that includes the necessary code to compile code, so to speak. And for that we can pick a lot of DLLs. There are some that probably exist on your system already. In my case, I can find one in, let's see, first was MSBuild, toolspath, autocomplete to the rescue, MSBuild to toolspath, that is. Which contains a lot of interesting tools for MSBuild. And inside that directory, there's one Microsoft.build.tasks, which should make a lot of sense. It's a Microsoft thing we're building, and it's about tasks. This one isn't so intuitive, it's core.dll. And what we want specifically is a specific task factory inside the DLL. And that's the code task factory. We could alternatively also use the Roslyn. The difference would be, I think at least was, we have the code task factory directly, which is the older one for .NET Framework projects. And I think the Roslyn code task factory is the newer one that you use for .NET, something like that. I'm not too sure anymore. I know it exists, and there's a difference between the two regarding the target frameworks, but I'm just going to use the code task factory. Now the using task, actually, no autocomplete, I don't want that. Using task, yes, like that. Requires some content, because this is where we write our code. Now let's let's keep that. Our code has to be framed as the content of the task first that we're running. So we start with a node called task that specifies the actual task that we're going to run. And inside here we have code, not code factory, code. Autocomplete, what's with you today? As always. And this is now the node that lets us actually write source code. And something we can do is we can hook into some existing methods that all tasks share. Because we're using the standard DLL here, we also have access to a lot of standard library code that is used for MSBuild. And that also allows us to hook into some systems we used before, just from a different point of view. I've used message a lot so far to get any output, but what it's doing internally is use the logging system for MSBuild. It's just adding messages to the MSBuild logging output, kind of. And we have access to that from inside our task here. There's an You have to imagine that you are writing right now code that is placed inside a method, inside a class that is already predetermined. Like at this point, we're just declaring these few lines of code. We told MSBuild that we want a class for an MSBuild task, which internally will have a method that is called when we call that task, called reverse text. And the code inside that method that we want is written in here. And so I have access to all the data that is part of that class, which is, for example, log. Well, the class log. And with log, we get log message, which is pretty much this task. Hello from source code. It's C# code, we add a semicolon, and in our method, we can just call our great new task called reverse text. We don't have to provide it anything in here, we just say call it, and let's try it. Hello from source code. You also notice it's not highlighted as important, it's therefore in gray. But it is custom code we're executing right now, C# code, as part of our build process. Which itself is pretty cool. But maybe let's make it a bit more useful. The task contains the actual code so far, but we don't want to just have the task itself defined, we also want to have the interactions between us and the task defined. And the interaction between us and the task refers to basically these attributes that we have in other tasks. For that, I have to define a parameter group. Another group. And what I can do here is define, for example, reverse text. Yeah, let's use first input text. Input text. Like that. Once I do that, I can use an attribute input text. And when I run my code now, everything works. If I remove this and just call it input text, it will give an error. So it does recognize that this is this property, or this attribute up here. It works after all. We're just not using it in any sense. Let's remove maybe that output, we don't care about that anymore. Actually, let's remove this one as well. Our code should give out input text, but in reverse. Let's do that. Input text is, because we defined it as parameter in our parameter group, now a property inside the class we are currently coding in. Bear in mind, we have a full class predefined with a method that's predefined, of which we write part of. We are inside a method surrounded by an existing class which now contains a property called input text. So we can just output input text directly. I do this, we get some text out as expected. but we want to have that in reverse. So let's write the full. Let's see, we have character array, reverse. I'm doing the classic way just to have some code here. Input text, new character, input text dot length. Not having autocomplete is a bit throw off, but and I equals 0. J equals input text dot length -1. Then j greater or equal to 0. Minus I. Wait, that's a comma, not a semicolon. And wait, I is plus plus, j is minus minus. Yeah, like that. And then reverse I equals input text j. And then this should be new string from reverse. I think I got that right. We do need to be careful with the symbols here. This greater signs is fine now. The less than would not be fine. I would have to escape then again. Let's try this. It worked. Some text, just in reverse. What happens if I don't provide that attribute though? I still have that property in my class, but without providing the attribute, we get an exception, a null reference exception. Unlike what we had in MSBuild so far, where if we didn't define it, it will be an empty string. In this case, we're talking about C# code, and in here we do have null. So input text right now can be null. We don't provide it. We can force it to be provided by adding an attribute and setting it to required. If I try to run this now without providing the attribute, required attribute or required parameter input text, I have to add it or it will not run. So again, input text, some text. Running it again, and it works. But we don't always just want output. Maybe we want to use the values we generate in here for something else. There's an easy way around that as well. We add another one. Reversed text. Another property in our class. But this one should not be an attribute for our task down here. This one is supposed to be output. So I can't add this now as reversed text equals something. This doesn't work. It's not an attribute. Doesn't do anything right now, but it's not giving me anything. What I want to do is store that data in here. Yeah, I still have the property reversed. Yeah, that's fine. We store this in there. Reversed. That. Now we store it in the property reversed. And I made a mistake. Oh yeah, it's reversed text, not reversed. That's better. So code still works now, but I need to access the output of this task. Something we haven't discussed before. Each task can receive values from you through attributes, but each task can also provide you values back as output. And for that, you actually have to make it a full node, expand it, and in here, once more, you have effectively a group, sort of, where you define properties. But this time it's a bit special, because you cannot directly determine the names for everything in here. The nodes we add are called output in all cases. So every output we have is an output. No matter how many we have, they're all called output. The difference is the attributes. First, we need the task parameter. This is us telling the system what this output is for. Because every task can have many, many different outputs. And we want to specify, we care about this parameter, reverse text. And then we can add the property we want to store the data in using a property name. And this can be a property that exists or one that we make up right now. Reverse, like that, maybe like that, yeah. And then like this, and have a full-on property. Then we can just reference from this point on. So run this. We get the output internally from the task itself, from the log method, and from the output parameter we have. And this style of getting output works for every task that provides output. If you look up the documentation and it defines any output parameters, items, properties, whatever, this is how you access it. You expand the task and add output nodes, which define which specific output parameter you're interested in and where to store it. And it's not just for properties, you can also have names, items, which might require some changing in here. Right now, this is just the default, which is just a string. We can, however, specify the type of the parameter. So I could go system.string, set.string, and use just string, but we're interested in something a bit more interesting. I forgot the name. I wasn't prepared for that. I didn't think we would actually talk about the item output. There is a built-in type that you have access to through the namespace. It's part of the standard set of classes and the standard libraries you have access to in the context of MSBuild. Just like you have access to the log method just because it's predefined. You have also access to that specific type because it's an interface that's defined in that. It was something with item. And you would specify that in here to tell the system what I return here is not a string, but this specific interface type. And then you can, down here, expect an item that is treated as an actual item in the MSBuild context. So normal properties are in the C# code just a string, but for items in MSBuild, there's a special type in C#, or in your custom code that deals with items, because they are a bit more special. Because they're not just straight up strings. Got the name. But that is something you would add in here. Parameter type. But you can also have other types. Like that. Or maybe let's count. Let's make it like this. And parameter type equals system.in32. We have another optional, not required, optional input parameter. But this one is dedicated to an integer. And let's add one in here. Count equals 2. And then for int 0, less than count. Let's press I. Oh, yep, I have to escape, of course. So ampersand less than. And count now determines how often we output the message in our output. Now we get 2. We set this to 3. We get 3. And if we put something that's not an integer, we get an error. Because it cannot parse it to an integer. We can, though, leave it out completely. It's an optional after all. And then it will just use the default value. Though in case of an integer, the default value is no longer null, as it was with a string for the property. It's just 0. So we simply don't get any output anymore. And the same way, you can also provide a parameter type for input for items. So instead of providing a property up here or a simple string, you can also provide an actual item with everything you've added to that item. Again, I cannot remember the type and I'm not going to look that up right now. What's left in here? Oh, the usings. I forgot the usings. You might need some external libraries that are not part of the standard set. And for that, you need to include additional references in your task. I'm not sure why it's in the task and not a separate thing. But in any way, we have for one reference. And reference include. You can input a reference to a specific assembly. System.windows.fonts, for example. And it's like when we go to one of those projects on the right here and add a reference to some assembly. If you right click on the right on one of your projects and you open the add reference menu and you get the selection window, I've showed that once in a stream before. That's basically what we do in here, to add a reference to library and then to actually use that code in our code, we add a using statement effectively, which needs the namespace we want to add, and that in my case is to just that. And what we do here is we can now from windows.forms call the message box green code. Yeah, that should work. We'll run this. You cannot see it, I think, but here's the screenshot. This is what's happening right now. I got a message box appearing in Windows. And once I click that, the code continues. Also something you might pick up on. I run this code, and you see at the bottom here, it's stuck at hello world. It's not continuing with the build because I have my message box open, and so it is stuck in this call. This code is still running, it's stuck in here, and only when I hit the message box will it actually continue with the code, finish up and finish its task, and continue with the rest of the code. It's stuck in my message box. I hit OK, it continues. So that's also an interesting way to add some interactions with the user, with the programmer during your build. Maybe there are important steps where you need confirmation that you are allowed to do something. Maybe your build includes steps where you upload data to your local server or make some requests somewhere. And you want confirmation that, hey, is this okay? Or maybe you're running that as, I don't know, stress test for the coder. Are you actually paying attention? Are you still coding? But yeah, whatever you do in here, it will hold the entire build process. It's basically single-threaded, your entire MSBuild. Whenever it's stuck in any task, in any target, it will pause everything. The only way around that would be for you to separately call MSBuild several times for different parts of the build. And I think that's it. That's the only piece left that was for MSBuild. Custom code. We had, let's see, talked about the base structure with tasks. We have properties, we have items, the weird ways they interact and can be used. Oh, by the way, the whole thing about items, the whole thing about the properties that are copied into its own unique copy for each target when you call them, that holds true for items as well, behaves the same way. So properties, items, the weird way they behave, how you can call different targets. We have default tasks that you can use. We have custom tasks that you can define yourself. There are property functions that allow you to use some predefined functions that give you a bit more ability to work with your properties. We have conditions that allow you to determine if a specific node basically exists or not, which you can use in clever ways. I think that was everything I needed to show you today. And that took a bit of time. Okay. Well, that VOD is gonna render a bit. Yeah, that's it for today. Thank you for joining in. I'm gonna take my meds and something to drink and something to eat, and we'll have plenty of sleep. Have a lovely Sunday.